Now that the basic floor circuitry has been designed and tested on breadboards, the next step will be to start moving the bulk of the floor circuitry onto perf boards so that it will work more reliably and can be properly tested. So here is the basic design. This is the AND gate for the reset inputs. And here is the inverter for the active low reset input. These are the two NAND gates that form the SR flip-flop. This is the LED driver. And finally, we have the output buffer to ensure a good strong signal. Ignore the diode near the buffer, the design was changed. Here's one I prepared earlier, complete with a nice 3D printed mounting tray. And now, we build the next one. Where the camera is, I don't have a very good setup for soldering, so a lot of this is improvised. There's no technical reason for the components to be so high off the board, just like it that way.
I don't think I can take this anymore. I might just break.
If anyone's interested, the music that I'm using just comes from YouTube's audio library. The header is handy for holding single pins in place whilst soldering. Sometimes I find it easier to tack the part in place and then resolder it.
I don't think I can take this anymore. I might just.
The position of the camera makes it difficult to see what is happening when using a soldering stand, so I'm trying to do it using just my bare hands. It's working out okay, but it is less than ideal. I will need to find a better solution, so please feel free to make any suggestions. plastic sleeves are offcuts from stripped wires. They are handy for preventing shorts, and I think they also look nicer. Normally, you would fit the smaller parts that sit closer to the board first, but with perf boards I find the order is often dictated more by the position. It would have been easier to fit the jumper before the transistor, but I rely on the placement of the bigger components for determining the placement of links, etc. It's probably not the best way, but it works for me. The first and last rows are exclusively used for the supply rails, so sleeving the jumper wires is completely unnecessary. I just like the sleeve jumper wires. Always tin the wires first. Here I'm using Baker's flux to make tinning easier. I don't know if it's the right stuff, but I've been using it for years and never had a problem. Tinning the wires makes them easier to solder and far more reliable. When sleeving jumper wires, twist the sleeve and it slides on easier. Because the solder pads are plated through, any jumpers that touch a pad could also connect with a wire on the other side. I used to be very careful to ensure that all jumpers stood off the board. By putting sleeves on the jumpers, I can be sure that the wire is not able to touch the pads that it passes over. When I solder the transistors, I splay the outer leads to hold it in place, then solder the center pin. I then adjust the position and straighten the outer pins before soldering them. Re-straightening the outer pins before soldering makes it easier to remove the transistor if it needs replacing, so I can use desoldering needles. There's a lot that you can't do with desoldering needles, but when you can use them, they make the job so easy. I still use solder sockets and braids when I have to though. screen and comparing the basic design with my progress so far to make sure that I've put everything in the right place. This is a very cramped board, so any mistake could result in the board running out of space and not being able to fit in all the parts.
think I can take this anymore. I might just break all the way hard and ache, 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 all the way hard and ache.
And that's it, finally finished. Well, I still need to check each connection then test it, but I'll do that off camera. On visual inspection, I found the buffer was connected to the wrong side of the base resistor as shown here. That was a 5-minute fix that was unlikely to have stopped it from working, but the extra load on the latch may impact reliability. I then connected it up to the test circuit, but it would not latch on. The LED comes on when the button is pushed though. The next step was to eliminate the reset circuit, as this could be holding the input low. As the inputs to the latch are active low, disconnecting this wire will stop the input from being pulled low. This did not fix the problem. This is not bad news though. We can eliminate the 3 transistors in the reset circuit as the cause of the problem. We can also eliminate the 3 transistors in the LED driver and buffer circuits, because the LED comes on when the button is pushed. That leaves only the 2 transistors in the latch circuit. When I inspected the board, I meter tested all the resistors going to the VCC rail and all of the connections to ground, as these being correct ensures that there's almost no way for a fault to damage anything, since all connections to VCC are current limited. This made one of the connections between the diodes and the collectors of the transistors the most likely culprit. Sure enough, I meter tested and found that one of the connections was open. The issue turned out to be a link that I'd forgotten to solder. I think that's a pretty good outcome, since there were only 2 fairly simple construction faults. These small boards have 8 transistors, 7 diodes, 11 resistors, roughly 40 wire links. There's a lot that could have gone wrong.